Perfect. Okay. Today, since the last lecture, we have already practiced some exercises concerning state diagram, and we have also solved the assignment 2. And I also published the grade, I think, and I have already sent you an email about this. This week, expected that by the end of this week, I will break you down, as I said before, to different groups. And I will give you guideline for the project. I will give you some topics. However, I will not give you a detailed description of the project. I will keep for each group to have different flexibility, how to set the requirement. So just I will give different, let's say, topics, and I will keep for you that you go ahead and build your own case scenarios and different requirements for the project. So I will not give detailed description. However, I will give detailed guidelines. So the description of the project, it will not be so detailed, just to give you this flexibility that you can make brainstorming to have different, let's say, use cases requirement. However, I will give detailed guidelines about the submission and the deadline for the project. There is another email I have already sent concerning the evaluation. Have you already received, just I want to know that, have you already received the link or not? Because I received from two of the students from other courses, they told me that they didn't receive an email about the evaluation link. So Jad or Janvi or Samranjit, can you tell me if you have already received the link? Just tell me if you receive it, yes, no.
I have received more than 5, I think, links. I got spammed with links for all courses. So yes, I did receive it. But I haven't done the evaluation. I'm going to do it this week.
Yeah, no, take your time. I send you the deadline. It is 12th of November. But my question that you have received it for this course.
Yes.
So you receive it as a junk email, or you receive it like other email that you received during the courses?
No, I received it directly into the inbox.
Perfect. Okay. It seems that these students that sent me an email, maybe they deleted by mistake or they didn't take care for the email. So that's good. So return back to the lecture today. So today lecture we have already finished the design. And before this, we finished the analysis. So the main core of the course, we have already finished it now, which means that how we make the analysis and design using object-oriented concepts and using different UML tools. So starting from this lecture and the next lecture, we will start this design diagrams and design model that we have already created based on the sequential process that we have discussed so far. Now, again, it is not a programming course, so I don't expect to write the program from A to Z. This is not a programming course. You have other programming courses that you have already dealing with or you have already taken before. So just we are going to give some examples how this design model, we can transfer to a code, because for all of us, all these diagrams that we have already discussed, it will be useless if we don't know how we can transform this design to a code. So today we will start with this. I think that we need one lecture or 2 lectures before we finish how we can transfer different design models to a code. So today we will talk about basic implementation steps, and we will focus more about design class diagram, how we transfer this to different classes. This is what we are going to do. When we talk about design class diagram, for sure, I'm talking about classes, methods, attributes in the classes, also the relationship that we name it association. And we have to consider different association types that we have already also discussed during before. And so how we are going to deal with different association and how we are, this association, how will be resembled in the code and how is going to be transferred into the code. This is today we are going to discuss during this lecture. Again, since we are based on unified process model, and unified process model has different phases. Who was waiting outside? Yeah, I admit. So since we are dealing with different in the unified process, from the first day in this course, we said the unified process has different phases, and each phase will have different disciplines. So based on whatever we said that the business model and requirements more done in the inception, and the analysis and design will it will be more discussed in the elaboration. By the end of elaboration, we start thinking about transformation, this implementation, this design to a code. Then in the construction, we finish the whole program. And we are more interested based on the course scope in here, in the inception and elaboration. We are at the end of the elaboration. If this elaboration, we have already breaking it down into different iteration. So I think we are now in the last iteration for the elaboration. Again, the number of iteration in any unified process, it depends on the designer or the analyst. So there is no standard number of iteration. It's up to you how you define your iteration and how many iteration you will have per phase in this case. So let's start with the basic implementation steps that we have. So what we have now, based on what we have already done in the design phase. So we have a design class diagram, the final one. We have interaction diagrams, the sequence and collaboration diagrams. This interaction diagrams that we used to enhance the business model and to make a refinement to the business model till we reach the design class diagram. So without this, we can't have this. And this is what somehow this final output was based on what we have already discussed in the interaction diagram. So this is why we said interaction diagram, there are more dynamic diagram. And when we talk about the design class diagram, we talk more about static diagram. And we also have the state chart diagram. This is so far what we have. Today we will go to, because design class diagram talk about different classes and different associations. So we will discuss the different type of classes and association that we will have in any design class diagram, how we can transfer this to a code. So just a reminder for you that interaction diagram show the basic behavior of some of the operations. So somehow they are more related to the design class diagram. And that state chart give us the complete lifetime of the classes. And normally we need it for the complex behavior because there are so much detail maybe in the design class diagram that it was based on the interaction diagram. We can see it. So this is why the state chart, we are going to deal with it at the next lecture, next week. Today we will deal with the design class diagram, how we can transfer this to a code. So if you remember in the design class diagram, we state each class name and the method for this class, plus the attribute for this class. However, we didn't have a full description of the operation or the method that's being here. For example, we said class student. It has an ID, it has registration, for example, process, or selecting a course, whatever it is, the method that the student is going to do. But we didn't tell in the design class diagram what this method do. So this is why at a pre-step before we go to implementation, so we need more detail. So we need more detail, and let's say it is not a formally defined, which means that this method, what is expected to do. So this is why we have to define some method interfaces. Let's say we name it operation contract. These operation contract or interfaces, they give us more detail about what is expected from this method to do. Again, in the design class diagram, we have the name of the class, the attribute in this class, the methods in this class, the operation, plus the association with other classes. If you remember, it will be like something like this. So you will have the class name, here will set attribute, and here will operations. And then we will have, for example, an association with another class. This is A, this is B. So we don't know, according to the design class diagram, we don't know each operation or each function or each method what is going to do. This is why before we'll go to the class implementation, which means transferring this to a Java or C++ code, whatever it is, we have to make more details for this method, like that we are going to define something, we name it contract or operation contract. Let's take this example. We'll have here bank account, and this is the name of the attribute, and this is the name of the method. Do you remember what's this? Can I have a volunteer here to give me a correct answer? Do you remember what's this?
It's the visibility, so private, public.
Perfect. Thank you so much, Chad. 100% correct. This is more about access control or visibility. We name it our access control, which means that having protected a private or public. So either when we are going to define different attributes and the method with what is expected to return this method, so we give the access, what will be the access privilege, or for this different attribute and methods. So before we will go to transfer this and create a class of a bank account, we should also define for each operation, for each function, an operation contract, like here. So what is the precondition? What's post condition? Precondition that if there is a special condition, especially for the attribute, before you execute this function, plus post condition what expected from the function to do, because post condition, which means that after executing it, as if you are executing the statements that will be mentioned here in this method, and what is expected to have different the final output for this method. So a contract will be a precondition at post condition. Precondition will talk more about the conditions that should be satisfied before executing this method, plus the post condition, what is expected the final output after executing this method to be, like here, new balance equal old balance minus amount in this case. So this is informal, which means that it is not, it's more like a pseudocode if you can, even though it is not a pseudocode, it's somehow more detailed definition about the function. It is not a code, so still we haven't started with the code. But we need it as a pre-step because this is not mentioned in the design class diagram, as I have already mentioned before. So now there is a big question said, okay, we are going to start with a top-down or bottom-up, which means that according to the class diagram, when I talk about top-down, bottom-up, I'm not talking only about inheritance, no. According to the design class diagram, you will have class A associated to class B, and there is a navigability, which means that A will call a method in B, or it will need an object from B. If you remember how, like this, for example, you will have class A here. So in this case, if we do it like this, class A, which means that class A, maybe it needs an object from B when we create an instance from A to make a message bypassing, because we said before on OOP, and I think that most of you should know this because you should have already finished with an OOP courses. So to pass message from a class to a class, you pass it using an object. So either if you want to pass message from A to B, so either you create an object in B and then you put the value on this object, and then B can write the value from this using this instance, or based on who or B can create an object in A and put a value from the value of this object, and then A can read the value from this instance. However, from the design class diagram, based on the navigability that we have it, so we can know that if this arrow coming from this, then A is going to message bypass to B using an instance from B. So in this case, so A need B, so you have to create A. No, this is a question. So A should exist maybe before B in order to, for the instance from B, in order to pass the message. So either we will start with A or B, because we are talking about writing code line by line. So either you start implementing A class or start implementing B class. So what do you think? Which one is better? Any volunteer to give me an answer? My question said, who we have to go from A to B in this case, or from B to A in this case? I don't know if it is clear for the question. I can re-ask you about it. If you need to me clarify more what is the question, give me one thumbs up. So, Paul, Kate, are you here?
Yes, I'm here.
So, is it clear that my question?
Yes, your question is clear.
So, do you have any feedback that you can share with us?
I'm still thinking, but I'm not too sure if the answer is right. So your question basically is, which is a better approach, top down or bottom up in this case, right?
Yeah. When we have two classes, and one class, which is in this case the A, will create an instance from B to pass a message from B based on the design class diagram that we will have. So A will create an instance from B. So A will be in the top comparing to B in this case. So we start with A or start with B? First, let ask another question, Paul, Kate. And I based on the discussion, in our discussion, we can reach our solution. So, is it possible that two approach are correct? So, implementing class A and finish the class A methods and attribute, and within class A, then we can go ahead and make an instance from B, and then we go to class B, or the reciprocal. The first question, is both are correct?
I'm not too sure. I think that first you make class A, but if you suppose if you suppose decide to inherit to class B, so you cannot really call class B in class A unless you
Wait, Paul Kate, we are not talking about executing the code. We are talking about building the code. So it doesn't mean that when we are talking about top, bottom, or bottom up, which means that how the code is being executed. No, we are talking about building the code, which means that either we start building with A, and then we put an instance from B, and then we go to the build and B, and then when we will execute the code, when we are going to execute our code, for sure that all the code should be done. So don't think in this question as if you are talking about how we are going to execute the code. Yes, for sure, if you will not implement class B and then we create an instance from B, then the code will give us an error when we executed it. We are not talking about executing the code, because when we are going to execute the code or run our software, we should have already implemented the whole classes. I'm just talking about, so as if you are building or constructing a building. So if you are constructing a building, you will not use it after we finish all the whole construction. So the point now, how I will start my building.
So isn't bottom to a better approach? So construct.
First, let's answer this question. So before we'll say which one is the better, are both are correct? Can we start with this or this?
Yes, both are correct. They should end up with the same answer in the end.
Yeah. So in this case, we can either, so we have two choices in this case. Either we'll go from the bottom up or top bottom. So both we can start with them. Now the question was said, okay, which one is the best in this case? So I will give you an answer now. So as I said, A is going to create an object from B, because according to this design class diagram, A will create an instance from B to pass a message for B. So in this case, if you start with the top bottom, let's talk about the advantage and disadvantage. So class A, since it is representing the higher level, if you start with the higher level implementation, we can make an evaluation of the whole early. Why it's early? Because, okay, you can see A, start with it, and then before we go to B, we will double check everything okay, then we will go to B. So we can make an early validation for the system. However, if you are going to run this system, we need a temporary implementation for B, because B is not being ready. If you will go from B to A, so in this case, if you will go from B to A, in this case, no temporary implementation for B is needed. However, we can't make a validation to the system. So we have to finish B and A, then we validate the system. Why? If we start from A, we can validate an A and make a temporary. When I said a temporary implementation for B, for which example that just create a class B without going ahead for different detail in B, and we check the execution of A, everything okay, then we'll go to make a detailed implementation of B. However, you start with B, we have to finish B, then we have to go to A and finish A, and then we are going to see to validate if our solution is correct or not. So both are correct. However, A will give me a validation for what I have already implemented before I go to the next step to give a detailed implementation of B. When I talk here about a temporary or a stub, which means that I just have to create a temporary implementation for B without have a detailed implementation for this. Is it clear, Poolkit? Do you agree on this? Can you hear us, Poolkit?
Yes, that's clear. So it's better to create the top to bottom approach.
Yeah. So I think it's better now to start with the top to top bottom before we go to this.
Okay.
Okay, let's go now. We start about what is the basics for implementation, that we should have an operation contracts to have more detail about this method. Plus, we have to choose about going. By the way, the style of the building should be consistent. So if you have to go always from top down, so we have to start always the top down. So now let's start with a detailed implementation for the class diagram, that it is the main core of our lecture today. So again, it is not a programming course, so maybe I will use a Java coding here. However, somehow almost the same Java coding and C++. That just the main difference, maybe that there is no pointer here. In Java, we set the reference, which means that it is an object instance. So if you want to point to another object, you have to create an object from the same time to point for this object because they don't have the pointer concept in Java. However, in C++ they have a pointers option. This is the main difference between C++ and Java. However, the concept of the classes and the concepts of how we implement different access control, always they have the same concepts and same and somehow very similar terminologies in this case. So we will start first. We will not start with the association maybe, which means that if you are go to the bottom up, like we have a class A and a class B, so we start with a class A, for example. So we have to create a class according to the class name. And if you are not just, you don't have, you expect in this class that there are some methods that you didn't have a full implementation for this, because this is a pre-step in the implementation. You're just making an abstract, because according to the definition of abstract class, an abstract class can have an function abstract and can have a non-abstract function, which means that function with implementation and function without implementation. So if you believe that you are not going to make the implementation for the whole methods so far, just making as an abstract class in this case. And according to what mentioned in the design class diagram, so go ahead and make, for example, here cover date. It is here. I'm sorry. So if it is here like this hash code, which means it is protected. If it is a plus, it will be public. If it is minus, in this case, it's going to be private. So I will go and based on what I have already here, I will go create a class and then create different methods. So, and again, if I don't have, I have some methods that without implementation, I will go to the abstract class in this case. Let's start before we go to the association to talk about inheritance. So if we will have, for example, inheritance, so we have to take care about extents, like here. We'll have a booking, and for sure here in this case, we are talking about top, we are not talking about association here, we talk about inheritance. So we start with the top one. Booking we have already done. So after we finish this, we will go to the other classes, to the child classes, and we have to use the extents one based on what we have already. And then if there are some special attribute of method, which means that a method and attribute that are rather than the one that's being defined in the booking, we have already defined here. I think so far we are very familiar with it. So just we are going ahead to the class diagram and make this code. Now I think the implementation is more, it's something, I think that's more something new for us. I will not say it is complicated, but let's keep the word, it's more, we are not got accustomed to it. This is what we are going now to clarify today, that, so we have association. We have already talked about one of the association issues when we talk about A has an association with B. So if A has an association with B, and then based on this association, I mean, there is a relationship between an instance from A to an instance from B. Or there is a link in this case. And according to the multiplicity, we can know, for example, if it is one to many, which means that a specific instance from A will be related to different instances of B. And sometimes we will have a 0, 1, which means that an instance from A can have a link with an instance of B or cannot have so. It depends. And if it has an instance, so if A has it has a link with an instance from B, in this case, this instance A that is related to B, in this case, we will have to make this instance, or to represent this instance, in our code in this case. So as I said, in Java, the references, and in C++, we have a pointer that when there's an instance or a class related to another class, an object linked to another object. So we have to create an object from class B in A in order to make a communication with B. In C++, we can use object pointer. Here we have to use a references, which a reference, it is an object instance that is somehow from the same type from another object that is to be pointed to it. How we are going to implement this association? Suppose we're talking about an association like here, that we have an optional association. So in this case, we have a point and debit credit. And in the class account that we have already created it, for example, suppose that we have to create an object from instance debit card, or we name it here the card in this case. So, and when I said an object, because I said this link, again, I'm repeating the same word to be sure that you have already understood this, that you start with classes and you create different classes in Java or C++ about it. However, the link itself, it means that you have an object from the other part to make this link. So there is a link between account and debit card, which means that in this case, and we said account has this multiplicity. So it has this multiplicity and this has this navigation like this, which means that A, according to what we have already discussed before in design class diagram, A account, or let's say A side, will use an object from DB card to send a message for this. So in this case, within the class diagram, so within the class implementation of account, we have to create an instance from debit card. What we mean by maintain the association, I think that you have already this before discussed when you talk about OOP programming, that you should have a method that will, we name it get and set. So it will return the link one, like here, the get return the card, and that set that will set the link one, or which in another word that you will have a get and set return an existing link or an existing object you have already created, or set card that it will create an object or instance from the other class uses a constructor of this class. So it depends about how you are going to, how you have already, based on your design, you said that A related to B. So return the card, as I said here, that will return an existing link object. Here, set card, we said the card equal card, which means that the card is already this object we have already created it using debit card, which means that the base, it is an object from instance class debit card. And the card this that we are talking about it will point for this object from the type from the class B that we want to talk about it or send a message for this. Before I go to the compulsory association, I want to be sure that the concept of about a reference object, even though it is not a concept that concerning our course, it is more an OOP concept. Is it clear? Can any volunteer tell me if it is clear for you, or it need more clarification to help you to clear it more in a bit and using another way of clarification? So what about you, Jad or Samranjit? Can you tell me, Jad, for example, can you tell me about this? Are you still here, Jad?
Yes, I am. I understand references.
So you have already seen this before in OOP course.
Yes, I write C# code, so I'm very familiar with the concepts.
Perfect. So if you are familiar with this concept now, just what we are making mapping between the design class diagram and different programming concepts that you will have. So since there is an association from one to another one, which means that an instance from A can be related to an instance from B or linked when we have this optional one. Again, where it was. Here it is. So here we'll have this optional one, 0, 1, which means that an instance from account can be related to a debit card or cannot be related to a debit card. It depends. However, according to what we have already defined, sometimes we have a compulsory, which means that each instance should have at least one guarantor. So how we are going to transfer this as a code in this case? So, okay, according to the concept that we have already discussed so far, that whenever we talk about a link between two classes that we have already implemented, then we are talking about creating an instance from class B and class A. However, now there is another condition that if it is optional, which means that it can exist, it cannot. However, here we are talking about it is a must to be. And each instance from A, it is a must to have a link with an instance from B in this case. So we have to add a condition here that when we create an account, so because this is a constructor which means to create an instance from an account, to create an instance from the account, from the class A account. So whenever you are going to create an instance, you should create the linked object with it from the other one. So if G equal null, which means that if G doesn't exist, then we will make a null link error. We're going to throw an exception. So it is a must to do this. Whenever there is an object created from A, it a must to have another link to another instance from B. So in this case, we have to add condition. Before here, we didn't add this condition because it was optional 0, 1. So if it is a compulsory one or it is a must one, in this case, just we have to add this condition during our class definition. Okay, so we talk about one to many, one to one, and when we talk about one to one, at least one. And we have already talked about one to optional 1, 0, 1. And what about many in this case? Which means that each instance from the A side, like here the example is manager, can be related to many instances from the B side. So it doesn't have only one. So when I create an instance from manager, this instance can be related to many instances from account. According to here, when I said at least one, and it must be one, here in this case, when we create an account, we create with it the associated instance, G. We created one instance here, and we have to be sure that this instance is already being created. Here now, a manager, let's say an instance M, will be linked to according to the design class diagram that we have, is going to be related to different instances of the account. So in the manager class, so when we are going to go about the maintain association, which means that the methods that will create this linked list, linked object, in this case, it's going to have a vector, for example. Doesn't mean that we should have all those vectors. We can use any data structure that has a flexible size, but the vector is one of them. We should have a vector of object in this case, and we will add different object to this vector in order to be sure that any instance from manager can have different instance or a link for different instance from the B side. So we are going more and more and more about bi-directional association. Bi-directional association mean again in design class diagram, sometimes you will have a bi-direction. It's not only one direction. A linked to B, then an instance from A will have a reference to an instance from B. It may have different reference if it is many. It can have or cannot have if it is an optional, and it should have one if it is a compulsory or it is a must one. What about this case? When we will have a bidirectional association, and this we can have this in a design class diagram. So what do you think about this case? What we have to add to our code in this case, that to be sure that this bidirectional one we consider it in our code. So here, an instance from A will be linked to a reference in B, here which is the debit card, and also a one in B, an instance from B will be related to a reference or related to an instance from A, which means it needs a reference to this instance in this case. Okay, so I think that the answer is somehow, the naive answer will say, okay, then create a reference in A to B and create a reference in B to A. Good. This is good. Yeah, this can be, or that's how it should be. But there is a big question now. If I create an instance from A, put it in B. However, when I create any object in A and B, it should have also an instance from A. Again, according to the bidirectional association, each instance from A can be related or linked to an instance from B. This means that when I create an instance from A, I have to create the reference to it from B. This is normal. We have already done this. So we can add a set method and pass the reference from A side. However, also on B side, we can create an instance from A and passing to an instance from B as a reference. Aha. So, but now there is a big issue that we have to consider it here. So suppose that you have an account 1. Before I will go to here, account 1 and account 2. When you create A1, you make a link with D1. And then when you create A2, it should be linked to D2 in this case. A1, if it has, because here it is an optional one. Let's give another example. A1, A2. And let's make it in lowercase because object should be lowercase. Here A1 and this is A2. So here it is optional, which means that A1 can be linked or cannot. And suppose that A2 is linked to D1. So we should be aware that A1 cannot be linked later to D1, or A3 can be related to the same one, because we are using a reference from the other one to make message bypassing between two objects. This object here like a suitcase, so like a box. So me, Amjad, I want to pass a message for Jad. So I create a box. I name it Jad, J1, and I put the message and send it to Jad. So, and Jad will again send another box, name it I1, and send a message for me. And this we will keep this communication using J1 and I1. If I want to communicate with another instance from Jad, J2, so I have to use another box. I can't have to use the same box that I do it for J1, because in this case, this message was for another instance. So a big question here, or a big aware, we should talk about it, about referential integrity. Referential integrity means that we should be aware that since we have a bidirectional one, if it is one directional, it's okay, because always we create an object and go to this one, and then I expect one way. So when I create J1, J1 will not go back and talk with me from using back a box, and I should keep the box of J1 and A1 should be related to the same internal communication, because they are talking about such kind of communication. However, this is in bidirectional. I should be aware about it, because I should be this two instances or two references, they are consistent in a way now based on this communication that's taking place between two these instances. So account 2 will go to this card A, you see, and then this is create the card, and then this card go ahead and talk with A1. It doesn't talk with A2. However, it should talk here. If I go like here, create account 2, create account 1 and 2, and then create, and then I pass for A card, account 1. You see, when I create A card, I said the reference for you is AC1. And then I said AC2, suppose that I made this mistake when I am executing my code and said set card A card. However, this A card is supposed to communicate with who? With account 1. It doesn't supposed to communicate with account 2. So in this case, we should make a restriction for this, because according to our code, this can be executed. Because account 2.setCard equal A card, account 2 is from a class named account, and in this class there is a method named setCard, and this method setCard take any object type from debit card. So this is a correct, it is a correct illogical execution for the code. So an object from an account executing a method that is being already defined in account, and this method take an object with type debit card. But if the communication between account 2 and A card should not be done in this way, because A card is expected to communicate with account 1. So this is the referential integrity that I'm talking about. This is why I have to maintain this when I talk about here using this method set card or add card, according to you what we are going to use, which method, I should be sure that here, again, to minimize the human error, because your code, you as a programmer, you write a different code. This is why when we make the access control, we said, okay, protected, private, public. Maybe many students, when they start writing their code, they said, okay, they're all the same, public, public, private, private. Or maybe they will use always public. So there's no restriction, so always you have to use public. But you should sure that this code, because it is an OOP code, anyone can use your class and extend to it later, based you are working in a company, and then anyone then can make an extend to your class, and then start working with this class, go further to another work. So when you create your code, even though you know how it should be executed, you should have to all the restriction in executing this code in order not to have illogical, or that we said that it will be executing error, not a building error. When this code is going to be built, everything okay, but it will give you, if it will be misused, it will give you another result rather than expected one. So this is why you as a programmer, even though when you are going to execute your code, you know how it is a code sequence, however, you are going to consider the whole restriction in your scenario to be sure later if anyone, rather than you, is going to use this code to further implementation, you have already put all this restriction indeed. So according to here, so rather than set card one that I have already, this set card that take one, I will go ahead and make add card. And the card new duplicate, I use this, which means that create this to one this using this add card method that I have already talked about it, to maintain the referential integrity that we have already discussed. Immutable bidirectional association. So the bidirectional that we have already here discussed, 101, which means that an instance from A can have a link to an instance from B, which is an account from D debit card, or it cannot, like here, account 1 and account 2. Account 1 has a link, account 2 doesn't have a link. When we talk about immutable, one-to-one relationship, which means that I think that you should be also from the OOP somehow this terminology immutable. When we talk about immutable, I'm talking now about immutable association. But also there is something about immutability about the classes. We said that a class is immutable. I'm not talking about this case. I'm talking about the concept immutable. I think that you should be familiar from this from the OOP also. Any volunteer tell me about immutable class, what we name it in Java, for example, or C++? Immutable class, which means that if you create an instance from this class, you can change it later. This is immutable class. Do you know how we can make this restriction in coding? I'm not talking about immutable association like here. I will talk about it later. But just about the concept of immutable. Anyone has any idea about immutable one? Prabjot, you join us. Okay, Pulkit, go ahead.
I think if you want to make a class immutable, you just use the keyword final in Java to make it immutable.
Perfect. You are 100% correct. Thank you so much, Pulkit. Yes. So we can use final, which means that in this case, when I said this as a final class, any instance that later can be created from object, we cannot make any further modification for this instance. No further modification. Here, when I talk about immutable bidirectional association, when I said immutable association in general, which means that this association, when I said A is related, let's say we have a class account, class guarantor. So we create an instance A1, and this A1 is related to G1. So always A is only when we be related to only a G1, and G1 will be only and only related to A1. This is an immutable association that we should consider it in this case. So if our design class diagram, maybe this is very specific one, and maybe you will not always have it in your design class diagram, but we should discuss all cases that maybe you will have based on the design. Because when you start your design, based on that from the beginning of this course, we collect a requirement, then we make the analysis, then we make the behavior analysis, till we reach the design class diagram based on the domain model that we have already done. So based on this scenario, we didn't think about coding. We're just thinking about modeling, how we are modeling this. So if your design class model has such kind of restriction, having this bi-directional, and immutable. So before that, we talked about bi-directional, it was not immutable. But here we're talking about bi-directional and also immutable. As we did before that, make this referential integrity, consider the referential integrity always in our case, which means that always you have to consider this referential integrity. And also now, we have to consider always that to keep immutability, if it is a correct word to use it in this case, for this bidirectional association. Before I go to code, which means that if I create an object from a class account and I name it A1, an object, and this will be linked to G1, which means that in the construct of A1, I related G1, and G1, when I constructed it's related to A1, so they always be linked to each other, and they will never can be related to any other instances in this case. So how we can make this whole so we here then we will going to create a further method here. Some likely methods that we said get set, but we will have my J and my A. So before this we said in general in a class we had get A, set A, which one talk about setting the link for this. However, here we said my, because this instance will be used only by it and cannot be for somebody else in this case. So we will have something we name it get my in the account and set my guarantor, and here in the guarantor get my account and set my account in this case. And we are to be sure here, if there is a link, it's being already done with another one, to be sure first that if A, either it doesn't have or it have, we are going to change the link in this case to keep it as it is in this case. So in the class account, set my guarantor. You have a new object, you create an account, A1, and then you execute set my guarantor. First, you should be aware that this guarantor that you are passing as a reference is not a null, because this relation is a compulsory relation, one-to-one. So it is a must that each account instance will have a link to an instance from G. So first, we should be aware that this reference that we are doing, it is not null. We finish this. And if it is not null, we should be aware if it is a new one or not. Because we said that each one should have only one in this case. So we said, if it is not a new G, so it is one that is being already created before in this case, previous guarantor exists. So if there is a previous guarantor which means that for A, for the accounts that we are talking about it, in this case, then we are going to remove it for this, because I said it can be only one and only one for this. And we will said, okay, this is the then because this a reference is this is the reference, and it refer another object. The reference cannot be changed. So the reference cannot be changed in this case. However, this reference, if you want, you can change the one that it referred to. The reference should keep it. This is why I said, if RMG does not equal on my new G, which means there is an existent one, I said, okay, my G now equaling new, but I keep it my G here. Else, remove it else in this case, and I said then equaling new G in this case, and then set my A. The same scenario will be done also from the other one, the other guarantee. The same scenario that we did it here, we'll do it in the guarantor. So in this case, setting or getting, now maybe you are more concerned about set, because get just return the linked one. About, however, the set, it's one the more concerned about is that should be sure that always account A has a guarantor one, a refer object that refer to an instance from G, plus is the only one for this, and always one and only one from both sides. So I think this is, yeah, still maybe we talk about association in class, but I think this is one before that we finish, qualified association. Qualified association, if you remember also, we talked about when we talk about design class diagram, sometimes we are going to define an attribute that you believe in this communication, it is a key attribute. So the key attribute is a qualifier, which means that among an account number is something related. It is an attribute in the account table. However, we said if from this attribute, it for us, I think in the lecture, when we talk about the lecture, we talk about university and the student. And maybe we said at that time that the student ID is the qualifier, which means that in this link between these two classes, there is a key attribute that talk about, we talk about key attribute that will be used in the communication. Here it is the account number. So this qualified attribute, which talk more like an index in this case, how we are going to transfer this to a code, how we consider this in our coding or on our implementation in this case. So just now I have already revised the concept of a qualifier that we have already also discussed before when we talk about design class diagram. So you have a bank here, you have different account number, okay, and this account number, you use it as an index in the communication. By the way, when we talk about a multiplicity with a qualifier, now we are talking about more than the multiplicity for using this qualifier. So I think that we need a hash table here. When we talk about hash table, why hash table for this? In Java, a hash table, you will have a key and you have an object. Because here, still we need an object. Again. If you're talking about Java, so if a class A want to communicate with a class B, then an object from A should have a link to a reference from B, which is an object referred to another object from B. However, plus this object, there will have a key for this object. Because whenever you create a new object, like here, the case here, whenever you create an object, this object should have an account number. So it is a key, a unique identifier for this object. We're not like the same when we talk about student and university. Whenever you create a new object from a student, it will have a unique identifier, which is the student ID. So now in the whole image, we will have the object from the other side that we are making this communication between two classes, like here, bank and account, or university and the student. And we have the key that is related to this object. And we can use this key to make the different indexing in this case. So this key, how we can resample this? So in this case, we can use a hash table. So when we create an object from the B side, this object has a key. So the key and object, we can put it in a hash table. I think most of you know the hash table. The hash table will be like a data container or a data structure that has a key and a value. Here, the value, it is an object. And the key, it will be the unique identifier that will identify this object, account number, student ID. So in this case, it is like before when we talk about a vector. If an object from B can have different instances from A can have different instances from B. We said in this case, A create a vector and put different instances or different references that refer to different instances in B. Here, because we need the object and the key of the object. So we can use a hash table, not a vector. And in each element in the hash table will have an index, and this index will contain two values, key and a value. And here, then sending a key, we can pick the related object or reference that related to this key in this case. This is why we need a hash table in this case. And then we have to create a method named add account and remove account. They will add, you see? So we are going to add the reference object plus the key of it, put them in a hash table. When we have a multiple instance, we use a vector because a vector can be used. However, here we're not talking about multiple. It can be also multiple instance. We are not talking about this. We are talking about that in A side, here the bank one, we should have this account object that we are going to make a reference to it in our class bank. We have to add the key. So where we are going to save this data, we are going to save it in a hash table in this case. So hash table, we can insert a data using the key and the object itself. And then when you are going to retrieve the object, just you are going to send the key in this case, and then you get the return object in this case. This is, I have already discussed with you that what is a hash table mean. It is a data structure associated key with a value. Here the value, it is the object itself. So, and normally we can use it sometimes for sorting, like here, this is the key, this is a value. Again, the value in our case will be here the object. And then you will have different index for the whole data is being saved. And you can make different sorting if you want based on this. Last point. Last point about association class. Association class as we have already also discussed before, in the design class diagram, we said that we can have an association class. Association class doesn't mean it is a class. It is as this association class. Do you remember, anyone remember why we use association class before? It is something related to the association, if you remember, just to make a refresh. Anyone, any volunteer here, tell me what we mean by association class? What about you, Prabjot? Can you help us?
Probably when we have some attribute that is related to the association itself, like marks here.
Our smart lady, yeah, you are correct. So when there are some attributes that are related to the association, which means that when this association happened, when this link executed, there is some values that being stored in attribute, and this attribute will be related to this association. It's not related to one of the two classes. So according to the design class diagram, it is not a class so far. This is why we put it like this, dotted, if you remember. So, however, now when we talk about it here in the design class diagram, we are going to create a Java class for this. We have to deal with it as if it is a class in this case. So here, we'll have in this module and this, as we will have different registration. So we'll go like this. We have like this, and when we create a class, we name it registration. And since this will be, there is a relation between the module, for example, and registration, then we are going to make either with a student one or with a module one. So either we make a module related to the registration, and then registration will be related to the student in this case. When we talk about relationship between classes, we are talking about links, or we are talking about object references. So this here in the module, you will have an object from registration to make a link between module and registration. And in the registration, you will have an object student to make a connection to registration and the student in this case. So module will be related to registration, and registration will be related to the student. So you are going to create a normal class, we name it registration in this case. Today, we talk about all cases that we have association, and we talk about, because the design class diagram, what is a design class? Set of classes, attributes, method, plus association. For each class, you can create different attribute and methods as after we define the operation contract, and then we start with the association. We deal with different association as we have already mentioned. So I think now, based on this, if you have a design class diagram, you can go ahead and make your you can make your implementation to get all classes you needed. However, during your implementation, maybe you need even though the behavior or the behavior interaction diagram, what I'm talking about, sequence diagram and calibration diagram, we use it to create or to build the design class diagram. Still, we can use it here when we talk about defining the operation contract, because when you define the operation contract, we need more detail about the function. In this case, we have to return back to the interaction diagrams. I hope that all the points are clear. Today I will not make a group work, but for sure next week we will have, because there is another part related to the state diagram. I have to finish it to transfer this code. So today I will not make a group work exercise, but for sure we will have something about this. Will be next time in this case, after we finish the state diagram definition, about how we can also the state diagram, because talk about a more advanced behavior of to complete the whole lifetime using a state chart diagram that we talked about. So we should finish this next week. Any other question, I'm happy to answer you. Go ahead and ask me, because it's a good opportunity you are here. That if you have any question, go ahead and ask me about it.
So
you can go ahead now. You go ahead.
Okay. So wanted to ask about the group project. Like, when can we expect that?
Yeah, group project, I said at the beginning of the live session, in this week, by the end of this week, I will break you down to different groups using the Blackboard. It will be groups between 4 to 5 students, not more than 5 students. I will give a detailed guidelines. The deadline for the project will be so the last live session will be, since it will be 6 November. So you have almost 1 month. In this project, you will be asked to deliver a document talking about different design analysis issues. You are going to do it like the assignment. Plus, you need to make a presentation for your work. Either you will be in the last live session, I will not give a lecture, I will make it an open space to anyone who want to join the live session to present his project, his or she project, this group I'm talking about. So I will publish different topics or subjects. It will not be detailed one to give you space to have this flexibility concerning about defining the detailed requirement. So it will not be like assignment detailed requirement. Maybe it will talk about the general idea of different topics. I maybe make 4 or 5 topics, and each group can choose one of the topics. Even though they have another idea, another topic, they can send me an email and said, okay, no, we will not choose one of this. We can have our own topic and then send it to me by email, and then I will approve it. So this week I will publish the topics plus break you down different groups. Deadline will be 6 November. Either we will join the last live session and present your project, or if you cannot, that most of you that they cannot do the live session, in this case, you are going to record the presentation. You can make a meet a team meet between the group internally, and they will share with me the video in this case, because I want to be sure that what you have already written in the project, really you have already done this, plus you know how you present your work, because one of the most important point in design analysis, it's not like implementation, how you present your work to convince the other one. Like, for example, you are a company and then you have a client, and you're dealing with your boss, whatever it is in a company. So if you have different design model, you should clarify why you choose this model or why you did this in this way. So the same like I do it, maybe it will be a PowerPoint presentation, and then each one of you will talk. I will keep it to you how you manage it. Just share with me, because I will have a portion from the project grade based on the presentation. So to sum up, who is going to join the last live session can do it, in order that I will be with him. Maybe I can ask him a question, he can clarify it more. If he cannot, and most of you maybe they can do it, just record it with this presentation and share with me the recorded one. Is it clear, Prabjot? Do you still have more question?
No, thank you.
Go ahead, Jad.
Okay, so I just wanted to know, what can you tell us exactly about the final? I'm just worried that I won't have enough time, so I want to know whatever you can tell us about it.
But I have already published the final date, so you received my email, yeah, Jad?
Yeah, I mean, other than the date, for example.
I want to be sure that all of you that have already received the email.
Yep.
Yeah, concerning the final, I haven't started preparing it. I will start maybe in the next weeks to start preparing it. However, the final will be somehow very similar to the assignment one, which means that it will be an online one. So it will be an online one, but you will have a special timetable based on what. For example, if I'll give you 3 hours, as already here, but it's somehow it maybe take less time. So I'll put it as if it to take about two hours. That will, because sometimes when you work with online exams, student will be distracted because they are not working, they're doing the exam in the special place in the university. So I will consider first that if I will give you time, I think that the time duration is 3 hours, I will put it based on 2 hour and a half. This is the first point. Second point, it will be very similar to the assignment, which give you different case study, and ask you to make, for example, go ahead and give you a requirement and make the sequence diagram. I give you a sequence diagram. I said, okay, go ahead and pick the design class diagram for this. And for sure, I will ask some true, false, multiple choice question about conceptual, comprehensive. The same like I did in assignment 2. So what I can say so far, it is somehow very similar to the assignment will be the final. It will not be all multiple choice or true, false for sure. 20-25%, what I'm thinking so far, 20-25% of our grade will be based on comprehensive question. 75% will be about real case questions, giving you some requirement and ask you to deliver different models based on what we have already discussed in the course. I said in my email when I talk about the time that it cannot be the different part in the course, they are related to each other. So I can't say that there are some topics that I can get it out for the final. However, all the topics discussed so far in the course will be mentioned will be included in the final. Is it clear, Jad, or you want me to more clarify it?
Oh yes, so just to be clear, so in the final we're not going to have a full type of thing. So you're not going to tell us to make a use case, then make a sequence, then make a design. So it's just going to be one.
No, sure, okay. Sure. I should consider the time that you will have it, because it's not like requirements that I normally when I put an exam, even though it's the first time I give you a course, but I will solve it. For example, if for me it will take about 1 hour, which means that I have to give the student 2 hours. So, and now if this, and if the exam now it's almost 3 hours, so I have to put it that a student need 2.5 hours, which means that if I will solve it, I should take with me 1 hour. I will do it like this. So still you will have a use cases diagram to are going to draw it, but it will not be, for example, a real case scenario having a full requirement and go ahead. No, it will not be like this. Maybe I will ask you to do a sequence diagram and go class diagram, but the requirement will not be so sophisticated. It will be not a very detailed requirement, a very simple requirement that you can solve this model within half an hour or something like this. So no worry about it. And what I'm thinking about the structure, that to have 25% almost for comprehensive and 75 for the different model. But again, I haven't started with the final. This is what I have in my mind so far. But when I'm done from the final, still I can share with you some hints about it more. So maybe I will give you more detailed guideline about it. But to now, you should be aware that it will have a comprehensive 25%, 75% about drawing different model. However, this model will not be a very sophisticated one that will take a long time. It will take a very short time, and it will be very specific one based on the time limitation that we have for the exam. Clear?
That's clear. Thank you.
So much. If there's any more questions or any feedback you want to share it with me, I would be happy to hear. Okay. If no any more question or nothing to discuss more for today, just give me 3 thumbs up to leave. 1, 2. Thanks so much, Prabjot. Shapit. Okay, guys. Have a nice day. Take care all.
Thank you.
Thank you all.
Cheers, yeah.
Bye-bye.
Thank you. Bye.
Bye.